All right, we are looking at an application problem. So we have write an equation that would be used to generate the following table and then show how you determine the answer. So the first thing I'm going to do is I do have to do an equation. I am going to look at this. The minutes here, the first number set that you have, the data points, is always your x coordinates. Your y's are always the second set. So when it asks me right here to define my variables, I can just go ahead and do that since we have that part filled out already. X is our minutes, and our Y is our pages printed. And so that part is taken care of. So now we're gonna go ahead and take a look at what is going on here. So I see that our numbers are changing right here. They're going up by 1 every single time. And then over here, we gotta look and see what's going on here. So these are also going up every time. They're increasing by 12 each time. So if I'm looking at what is the equation, we're gonna say y equals, let's figure out what that slope is. Our rise over our run, or our y over our x, changes as 12 over 1, or just 12. So we put y equals 12, then we're gonna put the x there. I can solve what the real world meaning is for this problem. So what it's saying is that this is going up by 12, so 12 pages per printed. So I'm having 12 pages printed. And this is per what one of these is, and that's minute. So that's what this is telling me as far as the slope goes. And now we want our y-intercept. Now the y-intercept is not on this table because it is missing, right? So if I'm looking for my x coordinate, should always be 0 when I'm looking for this. So I would have to kind of go backwards if I wanted to do that. I can kind of go back here a couple of spots till I get to 0. So instead of me going forward 1 like I was there, I'm actually going to go backwards 1. And then I'm going to have to go backwards another 1. So I'm going to go, I'm going to go back 1, which is a -1. Again, we're just thinking about like, okay, if I'm going this way to keep going to the next point, if I wanted to kind of think about what would have happened previously to that, I could do the opposite direction and go minus. And then the same thing. So if this is going plus 12, plus 12, plus 12, if I backtrack it and go backwards, I can see what it ends up being if I go back 12. So if I go back 12 here, subtract 12 from 15, I'm going to be left with 3. And then if I subtract another 12 to get to where 0 is, that would leave me at a -9. And so I would have -9 for my y-intercept. So this is going to be -9 right here. Now the real world intercept here would mean that you'd have -9 pages printed, which does not make sense in this problem. But we'd have -9 pages printed at 0 minutes. So that's what that's saying in this problem, which obviously is impossible to do. And then it asks me, how long would it take for me to print 105 pages? Well, if I have this equation, my pages printed would be my y coordinate, and you just were asked to find 105 pages. So that is my y value. And so we're going to use that equation 12x minus 9 to solve for how many minutes it's going to take me, or my x. So I'm going to add 9 on both sides, and I'm going to get 114, which is equal to 12x, and then I want to get both the 12s on both sides, divide them so we can get x by itself, and that's 9.5. So basically what this is saying is that it would take me basically 9.5 minutes to print out 105 pages for this problem. And if you want more questions like this, you can find them on my YouTube channel, U1 Algebra. Check these out under the linear equations applications section.